My name is Luca Lo Schiavo. I am in Italy now. May I introduce myself maybe with this chart?
Yeah, let him share the screen.
Yes.
Yep, you have co-host.
Okay. You see?
Yes.
Thank you.
Yes, we can see.
Thank you. So who am I? I started working in regulation when in Italy was constituted the regulatory authority, whose name is now ARERA, in 1997. And I worked with the regulatory authority since last year, 24. And now I am with ERRA. ERRA is an association of energy regulators in several areas of the planet: East Europe, Middle East, Africa, Asia, and also Far East, Central Asia and also Far East. The association has now 48 associated members with very, very diverse regulatory environment. I work as a regulatory specialist at ERRA. They searched for a person with, let's say, expertise in regulation, and there was a selection last year, and I was selected. I have experience in, especially in infrastructure regulation, tariff, network development, especially quality and innovation, but also more recently in market monitoring and also, of course, let's say, rules for market functioning, both at retail and wholesale level. In Italy, we don't have nuclear, but we have a very long, extremely long decommissioning project, and I've been also engaged in regulating the company for nuclear decommissioning. I've also worked with ACER. This is an interesting thing for you, just to try to understand the differences between US and the EU. We don't have what is FERC in US. We don't have a federal regulator. We don't have a European regulator. We only have a European agency named ACER, this one. This is our agent of, maybe better. This one, ACER. ACER is the agency, European agency for cooperation of energy regulators, because in any European state there is a regulator, and ACER is the hub of the net, or the regulatory network, let's say. Please interrupt me if for any need of clarification. Sorry for my English that is not so good, especially in understanding your questions. So I start. I think I will say,
Luca, your English is a lot better than my Italian, so I will give you a break.
I suppose, but I must understand your question in English, not in Italian. I say that I probably will say things that are probably known. However, I try. AI training facilities are in this very moment the focus of attention. You probably know this white paper of NERC. I don't have to explain you what NERC is, but when I speak to European or other countries, I have to, because this extremely interesting and rich white paper pose a lot of problems, let's say, a lot of issues about what the training facilities can bring to the grid, novel challenges that these kind of facilities create to the grid, especially for these ramping rates. This chart is not from white paper of NERC, but is from this other technical paper published in August 25 by these three big companies in IT and AI. Very, very interesting. That explains that the scale is 50 seconds. 50 seconds, it's a vertical bar. So you can see how fast is the rate between computing phase and communication phase, between 90% thermal design power and 10% thermal design power. Very impressive situation. It means that we always think of data center as
Luca?
a traditional. Yes, please.
Can I ask a quick question? Is that at the interconnect, the building to grid interconnect, or is that a server rack, or et cetera? That strikes me as, with balancing an AI environment, a lot of those spikes will get leveled out. At least that's my understanding, but I don't deal with AI server farms to a great extent. So that is a facility chart we're looking at.
This chart is at the very beginning of this paper that is quite considerate, so I suggest you to look at it. But in my comprehension, let's say this is the need that they want to solve. So in the paper there are three solutions for this problem, and this is in the point of connection. This is the measurement, the point of connection.
Is that point of connection? Okay.
Yes. And indeed, the three solutions are, of course, at increasing cost and also increasing impact in operation.
I just want to add, Luca, would you share the slides with us? I'll send it back to everyone who attended.
Yes, of course. Slides are fully available. And also these are links that are usable. What is interesting is that I think, at least me, I had an idea of data centers as traditional, stable, predictable load profiles, the less problematic customers in a given sense. Indeed, with AI, things are really changing, and AI have two different, let's say, specialization, because some facilities are only for AI training. And here, in AI training, this is the most difficult customer, because the workload is synchronized by the algorithm of training. So there is this extreme variability, as we have seen, and therefore a big impact on the network. On a third point, let's say an intermediate point, the data centers for AI inference, so the operation, are more stable than training, but less than traditional data centers. And of course, the workload depends on user demand patterns. So I think that here the flexibility, I suppose, is very difficult to be introduced in training facilities. For inference facilities, probably, I suppose, I'm not, it's my induction that it can depend on the contract with the customers. As you probably know, the appetite for energy of AI is impressive. AI, the International Energy Agency foresees in a few years potentially doubling from less than 500 terawatt hour to more than 1,000 terawatt hour in 4 years only. And there are some countries like Ireland where this already is let's say a sort of nightmare. Of course, the operator have concerns about the possibility of load loss. This is a big problem documented by NERC review. and also for forecasting demand and connection queue. So all these are the problems that are in front of regulators and policymakers in general. An interesting data that I found in IEA report is that an average prompt of artificial intelligence requires 10 times more electricity than a Google query. Of course, this poses an enormous dilemma between AI and climate, because substantially the electrification of transport is summed to the new or the new ramp, let's say, the new boom of data center. About the boom of data center, we have to say that there are also some the first skeptical voices. For instance, The Economist published an article a few weeks ago with some, let's say, conscious considerations. But however, it's true that to cover this demand is very, very likely to arrive to more extend fossil fuel generation units, or where available, but of course with a lot of problems in siting and construction, new nuclear. But of course, this is a very difficult point. In Europe, the most impacted is Ireland, with 21% of national demand covered by data center. I find this figure enormous. In my country, Italy is 2%, France 2.2%, Germany 3%, Netherlands 5%. And as a whole, in Europe is expected to triple from 25 to 35. So from an average of 2 as a total to an average of 7 in 10 years. While in the US, from an average of 4 to an average of 9 means something more than doubling. So let's see. My research started from a very interesting case in Ireland. In Ireland, there are very specific reasons. There is especially a very special, I would say, tax regime that attracts a lot of companies here in Europe. Of course, there is a cool climate that is important for cooling systems. Also a good location and especially high quality digital infrastructure. But the network is very congested, and 4 years ago in the Dublin area, where there is a strong impact, 48% of electricity in that area is only for data center. That's really impressive. The CRU, the national regulator, as I said, every nation, because in Europe we call nation what you call the states. Every nation has its own national regulatory authority. So CRU called for a moratorium of connection for data center in the Dublin area. And you see, this is a comment from KPMG saying that this at first effect, let's say, at global level, because, for instance, Amazon stopped its investment in data center in Ireland to understand which was the energy policy issue, so this large users topic. What happened? In February 25, the regulator issued this consultation paper that is quite long and complex, I would say, 90 pages more or less, that is on 4 pillars. One, the most let's say, impressive, I would say, are energy self-sufficiency. So new data center should, because this is not yet a decision, it's a proposed decision, but not yet transformed in a decision due to resistance of industry. New data center should have dispatchable generation equal to maximum capacity, but and this requirement is totally technology neutral, but being dispatchable is not only thermal, could be also renewable, coupled with storage, so very costly. But if thermal, must be, they say, future-proofing, so hydrogen or biofuel compatible. So this means really costly as a rule, for one side or another, is not a standard generation. Grid operators must publish capacity maps, hosting capacity maps, and it's recognized that connection can be refused in saturated zones. Last, operational flexibility. Here maybe is not clear enough how much, but data centers shall provide demand response services during grid stress period, and this is probably another difficult point to be concretely enacted. Reaction has been not easy, not glad, I would say. For instance, this report from a law company in London, but acting also in Ireland, make a summary, let's say, of the position, and it's interesting because it put the focus also on the network planning process, because they say is too slow moving, and also there are too many objections and judicial review. So they hope that there will be a new act, a new law in Ireland. There should be, with mandatory timelines and so-called sufficient interest test in order to speed the process and reduce frivolous objections. It's a matter of fact that we are now in October, and the proposal issued, published in February, has not been converted, let's say, in a final decision yet.
That's because they're in the middle of an election season.
I didn't catch, sorry.
They just finished their elections about a month and a half ago.
Oh, is it the elections? Yeah.
Yeah. I have many friends in Ireland, including Jim Gannon, the head of GRU.
Okay. So, and another interesting case that tried to cope this problem, let's say, is a legal innovation in Spain. Let's say apart the blackout, that of course we can also talk about that if you want. This comes from a series, let's say, of new rule, but ultimately this is the last completing decision, July 25, substantially maybe not abandoning but overpassing the principle of first come, first served, because CO2 emissions are considered as a merit index for priority in connection. And there are also further criteria like electrification of industrial process and the green energy vectors. So this is a really complex approach, I suppose, not easy to implement, but to say, not when you ask for a connection, the more you are, let's say, green as a data center, the faster you are connected. So this is a really new approach. I don't know any other country in Europe with such an approach to connection. In my paper, I consider also other US cases, just to compare a little US and the EU. I don't know if you are interested about that. I, from Europe, tell you what happens in US, but however...
That's why we're here.
that probably you know much better than me. I was impressed, I must say, from the case of Amazon in Pennsylvania, where a co-location behind the meter with an existing nuclear unit was refused by FERC with a split decision 2-1, and the president, at time it was Phillips, dissenting in written. I suppose this is a rather rare case, I suppose. In Europe, we do have, at least in Italy, we do have possibility for dissenting. For instance, in France, they don't have dissenting. But I worked more than 25 years, and I don't remember a single decision, external decision, where dissenting opinion was used. Other kind of decision, not regulation. And in that dissenting, it's very interesting because these are his words. Electricity is the lifeblood of AI data centers. So it's incredible that such an essential input is not yet really considered for how essential it is. And he says we cannot vote against because it's a step backward for our leadership as US, national leadership. And affordability can be solved. Affordability is becoming the problem, we will see. However, the two, and as far as I understand, Phillips was a Democrat, and the two the two in favor of refusal, were Republican. The strange thing was that the first day of President Trump, Phillips has been changed, and one of the Republicans voting voting in favor of the refusal, was elevated to chairman. And 6 months after, the strategy for winning the race arrived, and substantially this strategy, as far as I understand, says that energy must follow the AI development. It cannot be a constraint. So, and indeed, the Republican commissioner elevated to chairman, as far as I understand, in August, resigned. And now there is, incredibly, a Democrat in FERC as a chairman. Correct me if I understand wrongly. So it seems that politics, independence in FERC, and AI merge in a sort of very interesting anecdote. The ERCOT model in Texas is much more flexible. And they ask for a more, let's say, a more focused investment plan, also with controllable load resource program, especially after above a given threshold that is 75 megawatt, with load reduction compensation. My paper was presented at the Energy Law conference, so it is much more interested in looking at differences, let's say, between European Union and United States. Here I use the word that I wouldn't use now, ex post. It's not ex post, it's case-by-case adjudication. But case-by-case adjudication means uncertainty in outcomes. You see, every country, every state has its own rule, and even some rules can be differently applied over time by the same decision maker. What is interesting, this is not in my paper, was not in my paper because I discovered it recently, is the PJM case. If I understood correctly these sources, it happened that in PJM, the long-term load forecast show a peak due to data centers, an enormous peak, I would say, because 30 gigawatt is more or less half Italy. half Italy peak in 6 years, only for data centers. So here really we have to understand if this projected demand will appear or not, because it's a matter of stranded cost. And the auctions for capacity market skyrocketed from $2.2 billion to $15 billion for the next year. So for this year, indeed, there was an enormous political mess, especially governor of Pennsylvania, Shapiro, asked to do something because it's not possible to have such a cost. And as far as I understand, PJM proposed two things. One is non-capacity backed load. We do have such a service in Italy, for instance, but I wouldn't apply it to data centers. So this is really a novelty, I would say, for new connection, with of course exemption from capacity market payment. And the other is very similar to Ireland: bring your own generation with priority in network connection. So it's a sort of mixture between the Irish case and the Spanish case. That seems that the world is smaller than we think. I conclude saying that if you are interested, just to have an idea, the European system has two levels of rules. European level has these common rules. We have coupled wholesale markets all over Europe with single marginal price, TSO unbundling necessary with regulatory certification. There is a possibility to choose among two schemes, but substantially TSO must be unbundled. There are European-wide network codes with a complex, let's say, management of these European-wide network codes. Distribution company must be separated from suppliers. It is not fully requested ownership unbundling to distribution companies, but must be separated by suppliers. And that's important, the retail market is fully liberalized also for household, with the obligation to have last resort supplier in case of market failure of a supply. We also have a EU-level energy community scheme that is something similar to US community solar for collective self-consumption. This is the EU level. At state level, we have each state can decide if and how much to support renewable. Of course, there are some common criteria for state aid, but very general criteria. As I said, each state, like Italy, France, Spain, and so on, have their regulatory authority. So there is not something like FERC, no. There is not an idea of global interconnection, European global interconnection network. Of course, we have interconnection, but there is not a regulator of this. ACER, the agency, can solve disputes among authorities, but is not a regulator. About smart metering, you probably know that Italy was the first country, I suppose, in the planet having a full rollout 100% in 2000, starting 2001 and completing in 2010, 80% in 2006. Then we are now at the second generation, already rolled out. The tariff system is established at a state level. Normally is hybrid system, OPEX and CAPEX, different treatment, but there is a trend towards TOTEX. For instance, in Italy, we do have. Normally at state level, there is a vulnerable customer scheme for affordability, typically for low income. And flexibility rules are developed at transmission system level, also because are part of the network codes, indeed are still embryonal at distribution level. I don't know how much time I took, more or less half an hour. This is more or less what I want to say you. I try to answer your question, but please help me with your fantastic pronunciation. Thank you.